When I was starting my first TypeScript application, I was a bit overwhelmed with all these options that we have to annotate types. Especially when you have object structures. Should I use a type alias or a class? Should I use an abstract class or an interface? Should I use an interface or a type alias? It's like a circle, right? And each of them has its own syntax, features, and of course, limitations. In this episode of Too Long to Read TypeScript, we will answer these questions once and forever. We will review the syntax of all the different type annotations. We will compare them side by side to find which one is more sufficient under certain circumstances. This will be a real deathmatch. So let the battle begin. Hello friends and enemies of my friends, it's Nikos here, and this episode will be some kind of recap. We will review what we've learned about all the TypeScript keywords on how to annotate object structures. In all the previous episodes we are using this track object here, which has a title, a released year, the journs, and this is favorite flag, which can be optional at some point. As we've seen, TypeScript will implicitly set the types of our properties here because we have this type inference feature. And if I hover over my track here, you will see that this is not just any other object. This is a track which has a title, which is a string, a released at property, which is a number. So what TypeScript is trying to do here is to basically recognize automatically what kind of types we are using in this object. And if I try to do something stupid, let's say if I would like to add a new property which doesn't exist, I will get back an error. And of course, if I try to change the title and set a number instead of a string, I will also get an error that we are expecting a string here, not a number. And now what I would like to do is hover my track here and copy this object notation here. So now I can go to my track, and this is how we normally set the type annotation, right? Usually here we can have any, or we can have, for example, a string, or we can have object, which is one of the special keywords that we've learned, which indicates an object. But there is another syntax we can use here, the object notation. And don't get confused, this is not the object that we use here to define, to describe the contents of our object. This is just an object notation that TypeScript has as a built-in feature. And what I can really do is paste the one that we got for free from TypeScript before. And here, this will work perfectly fine, because this is not just any object, right? This is now a specific object which expects all these parameters to be in place. Of course, this solution here has its limitations, right? We cannot reuse this object here. So if I have another track, then I need to manually describe this track once again, which is not that useful. So we need to define this somewhere as an entity, as a track, something. And then here we only need to say that, you know what, TypeScript, this must be a track. We know what track is and what it contains. And here's where the battle begins. Which one from all the type keywords that TypeScript provides is sufficient enough for our use case? So let's start with type aliases. So let's declare a type alias just to learn the syntax and talk about its features. So what I will do is copy-paste the structure that we had before and create a new type called track. And basically what I will do is paste this object notation and simply save the file. And that was it. Basically now I can go back to my object and define that this will be a track. and that works perfectly fine. So now let's talk about the unique characteristics of a type alias. First of all, you cannot basically redeclare a type alias again in your application. So if I have, for example, type track again in this file or any other file in my project, this will definitely not work because this is a duplication. Also, when you want to create a new object, for example, let's say that we have another track, I cannot really say new track because this is not a class, right? Track only refers to a type, but it's used as a value here, which means that we are trying to use the track type alias as a class, and this will not work. So for that we need a class. We cannot use type aliases to instantiate, to create objects. This will not work. But we can use a type alias to annotate objects. So, for example, if I have a track list, I can say that this track list is an array of tracks, and then I can assign an empty array here. So this will work perfectly fine, and this is a very nice use case of a type alias. In a similar way, you can use a type alias in your function parameters. So for example, if I have a function play which accepts a track, then I can say that this will be a track, and this will perfectly work fine. So now if you try to pass some value that doesn't match with this object structure here, we will get back an error. Now, one of the main characteristics of type aliases is they can support primitive types. So if I go back to my declaration here, I can use a union to say that this object will be undefined or it will have this object structure here. In a similar way, you can have, for example, a type here which will be ID, and this type can be either a string, or it can be a number, or it can also be undefined. I don't know for what reason you want to do something like this, but just for you to know, it is possible to use a type alias for that. But you cannot use any other type annotation that TypeScript provides to support primitive types. Another thing I can set with type aliases is methods. So I can go here and define a play method for my track, which will be a simple void method. And this is all I have to do, and then I can go back to my track here. You will notice that my track object is not compatible with the track alias, and what I can do is basically implement the play method. So my play method will simply play this track. And now they are compatible. But as you will notice, I cannot simply specify that this play method will be, for example, private, or this will be a protected property, because all these object-oriented related keywords are only available for classes. So don't try to do this, it will simply not work. So let me revert this change. So this means that type aliases are basically very similar with interfaces, right? Because they can fully support interfaces. The opposite, though, is not really possible. So you cannot use an interface to support everything that the type aliases support, because you cannot, for example, set a primitive type there. So this makes the type aliases a very, very handful keyword, which can have different forms. So, for example, you can use a type alias if you want to replicate an enum. Let's try this. Here I have a type file types, which can accept MP3 or MP4. And now what I can do is create a type variable annotated with file types, and instantly, if I try to assign a string here, you will see that I even get code completion. So I can assign that this will be an MP4 or an MP3. So TypeScript uses my alias file types here to simulate enums. Obviously, it will not let me have a different value from the ones that I already specified, and this will also not work if I try to assign a different kind of type. So this is how we can use type aliases to support enums. We will compare type aliases with enums later on in this episode, For now, what I want you to remember is that you can really use type aliases whenever you want. The most sufficient way is when you have some primitive types like these ones, for example, that you want to quickly set and across your project, or when you want, for example, to specify an object structure and you don't care about the OOP specific keywords. So type aliases are not really good for library authors. So if you want to declare, for example, an API, and this API is likely to change later on from the projects that you have, then it's better to use an interface, and we will see why later on in this episode. But enough with the type aliases. Let's go to the next contestant, which is interfaces. Okay, let's see the syntax of an interface. What I would like to do, because I'm a little bit bored, is go to my track here, hover over this type alias, and copy everything that we have here. And let's go here to our interface file, and now let's declare our interface. And of course we will use the interface keyword. I will not use the name track because it's already taken by our type alias, but I will use iTrack, which is a common way to name interfaces in TypeScript. Notice that I'm not using the equal sign here. I will paste directly the implementation, and this is basically one of the main differences between type aliases and interfaces in terms of syntax. So as you can see, my interface can fully support what we had before in our type alias, but I cannot have a primitive type declared here, because if I try, for example, to say that this is a string or this object structure, this is not gonna work because interfaces just support object structures. So if I have an object, or if I have an API and I want to define what this API contains, then it's the best way to use interfaces. So let's try to refactor my object here to use my iTrack interface, and as you can see, it works perfectly fine. You will notice that if I hover over, I see interface iTrack, so Visual Studio Code will not give me direct feedback of what this track contains, right? But if I control or command on a Mac click or hover, you will see here that I get the full implementation details about this track. And you can do that with any object or any interface in Visual Studio Code, or in basically any of the other text editors that we are using for TypeScript. So now let's go back to my previous examples here and try to battle test my interface. If I try to create an object, if I use the iTrack instead of the track, I get back the same error because I cannot instantiate, I cannot create new objects from an interface, right? Because interfaces don't have a constructor, they are just a description of how an object structure will be. They don't provide any implementation logic or anything else. So obviously this will not work. So now let's change this one here, and it works perfectly fine. So basically I can use interfaces everywhere to annotate the type. And the same applies here for my function parameter, right? Because this function play accepts a track, and the track can be an interface, which is actually one of the best use cases for interfaces. If you have a function and you are considering what kind of type you should use here, then if you don't have any class or any kind of type in your application that describes this object track, then it's better to use an interface. You can place the interface directly before or after this function, for example. You can also export it if you want and allow other people to import it and use it in their code. Finally, enum support, I think this will not work, right? Because I cannot say that I have an interface, file types, and this will have, for example, specific values. So this is a feature that only type aliases support. We don't even have the syntax here to implement something like this. So unfortunately or fortunately, this will not work. Another thing that interfaces don't support is OOP specific keywords. So for example, if I say that this is a private, protected or whatever, or read-only property, then I will get back that this modifier cannot appear here, because this is a class exclusive feature, right? Another thing that interfaces don't support is default values. So if I try here to add a default value, for example, unknown title, then this will simply not let me, because interfaces cannot have default values. And the same applies for type aliases, by the way. If you go here and try to do the same thing, then you will get back a very friendly error, because type aliases are not classes. This is another exclusive feature of classes. So what are the exclusive features of interfaces, you may ask? So first of all, we can extend an interface. I can define the interface multiple times. I can have another track here, and I can add additional properties if I want. For example, I can say that the length of the track is a number. And now check this out. If I go back to my track object, I receive a very friendly error that length is missing from the type iTrack, right? Because now these two interfaces have been merged, and this is one very nice feature of interfaces. Of course, now I don't want to have this error, so what I will do is keep this length property optional, and then my track object will be compatible. Here I can of course specify the length if I want to, but I'm not going to do that. And this is a killer feature for interfaces. Basically, interfaces are the best to to create a shared library, or to write type definitions for existing libraries. So another killer feature of interfaces is the fact that they can connect unrelated classes. So for example, we can have a class YouTube video, which implements my iTrack interface. And now you will see something magical is happening here. If I hover over my class here, TypeScript says that it incorrectly implements the interface iTrack. And that's because none of these objects are members of this class here. So what I would like to do is copy paste all these properties and define some default values. And as you can see, my YouTube video is now implementing fully the iTrack interface. And the coolest feature is that now I can have another interface, iSpam, and this interface will have another method, annoy viewers, which is a void method. And then what I can do is go back here to my class and add this interface iSpam. And now what I will get back is another error that this class doesn't implement the iSpam interface. And of course what I can do here is implement this annoy viewers function. You will see that Visual Studio Code automatically pre-filled everything from me, and now I have to simply write the implementation of this method here. And now you will ask me why this is a killer feature. Because I can have now multiple classes that implement these two interfaces. So for example, I can have another class like emailer, for example, or email daemon. And this class will implement my interface iSpam, and it will have a completely different set of properties and different methods, right? But all we want to do here is add this annoy viewers function, which will work completely differently. But we don't care, because that's the beauty of interfaces. They can connect unrelated classes. My YouTube video class has no clue about this email daemon. They are not related, nobody inherits from the other, and but they share this common logic. They implement this ICE-PAM interface here, and this is a very nice way to structure your code. And that's more or less what an interface is all about and how it compares to the other type annotations. So best examples for using an interface, if you have, for example, an API and you want to define this API, if you have a library and you want to share, or if you are declaring type annotations for some third-party library, then use an interface is a very good idea. Also, if you have, for example, React components or any other components, and you want to specify the types for your props, then use an interface. It's a very good idea, and you can extend it. So you can share, mix and match interfaces and create your own type system. If you have a function, you can use interfaces for the arguments, or you can also use interfaces to create classes and implement specific functionality. But enough with the interfaces, now let's go to our next contestant, which is classes. That time has come. Let's create our track class. So what I will do is, again, because I'm a little bit bored, I will go back to our interface and copy the implementation and go to a new file and create a class. I'm using the class keyword, and then I will name the class track class just to differentiate from all the other objects. And then boom, I can paste the implementation of our interface with all the properties that we have used. You will notice that for the class implementation, we don't need the equal sign. And you will also notice that my screen got red, and if I hover over these properties, you will see that there are no specified implementation initializer for these properties and methods. So what I can simply do is go here and define some default values, and this will pass the issue. Obviously, this is not enough because we need a way to help the consumers of this class to instantiate, to create objects. So that's why we need a constructor. So let's create a constructor. Here I found a typo. This is actually not Zernes, it's Zeneres, but I will leave it as it is just because I don't want to refactor everything. Please don't blame the content creator. Okay. And this is my constructor. It basically accepts all the properties as parameters, and it assigns them to this instance of our object. So that's perfectly fine for now, and as you can see here, we have an issue with our play method. So basically, the play method cannot stay without any implementation, right? Here we have two options. We can either specify the implementation here, so basically we move all this implementation of our play method inside our class, and this will work perfectly fine. Another option is to say that I really don't want to specify the implementation of this method here. And what I can do is specify that this is an abstract method. And for this to work, we need an abstract class. And now let's go back to our object here and let's use the track class instead. And you will notice that our object is compatible with this class, but you will also notice that something is not right. For example, here, this is a void function, and if I go and return a value here, let's say that I return true, this will not throw any error whatsoever, because we are doing something completely stupid here. We are trying to bypass the constructor of the class that we have perfectly defined here, and we are basically saying that I have an object, and by the way, this object I want to store it here in the track, which must be compatible more or less with this track class. It's not a very good approach, I would say. So type aliases and interfaces are very, very nice to use as type to annotate, to guard objects, but classes, I would not use them. So this example here is a nice example to avoid. Instead of that, we can use the new keyword to instantiate objects, because a class is essentially an object factory, right? It's a blueprint for creating new objects, and that's why we have to use classes. So first of all, here I have a full control of how these properties should be generated. So for example, I have private or protected, or even read-only keywords or static or whatever I want. I have full OOP support when I use classes. And as you remember, I didn't have full support for these OOP keywords inside my interfaces or type aliases. So this is an exclusive feature of classes. Another thing about classes is that they are available at runtime. Interfaces and type aliases, they will completely removed from our actual JavaScript files. These are keywords that only TypeScript understands and only TypeScript uses, right? Because they are meant to be used solely for type checking. They are not meant to be used for our actual application. So that's the main difference between classes and all the other types that TypeScript provides. Actually, classes are not a TypeScript thing. This is a JavaScript thing, right? And we should not use them for type checking. But we can leverage the features that our classes provide. So one of the features is that we can use the power of our constructor to instantiate objects. And let's see how this syntax differs from the previous one. This is an abstract class, so let me remove this keyword and let me add an implementation for this play function. I will basically copy paste it, and yeah, now we can go here and use our track class to instantiate an object. So as you can see, I have full code completion support. Visual Studio understands what kind of properties are required. So let's add these properties very quickly, and more or less this is a way that we can use a class to create objects. So here I'm not just creating an object somewhere in my application and I use a type annotation to guard this specific variable, right? Here I'm using the class constructor to create an object, and then I assign this object here. So now, as you can see, if I hover this variable here, I can see that this is automatically set to a track class, but of course I can go here and use this track class as a type annotation. Now let's go to our other examples that we had before. Can we use a class to define like a track list? Of course we can. So this is a list of objects, or a list of track class objects. So this will work perfectly fine. Can I use a class as a function parameter? Well, of course I can. This will also work perfectly fine. Can classes support enum? No, they cannot. So this example here will not work. Can classes be used to implement them as interfaces? For example, if I say that I want to implement a track class, well, the answer is yes. In TypeScript, it is possible. And if I remove my properties, you will see here that the YouTube video is not implementing correctly the track class. So let me put them back. And that's another usage of the class. I would not really recommend you to use them in this way. I would prefer to use an interface instead, but TypeScript allows this. Of course, by using classes, we can have full inheritance support. So here I can create a class video clip that extends my track class. And here I get back everything that the track class contains, and I can also customize it in order to support video clips, which is a very powerful feature. For example, I can override the play method and have a completely different implementation. The other types that we've seen so far are not supporting inheritance, right? Inheritance is a little bit similar with this implements keyword here, but they are completely different because when I extend a class, when I inherit from a class, basically these two classes, the track class and the video clip class, they are related, right? Because the video clip is like a subclass of my track class, which is the parent class. In comparison with the interfaces that we've seen before, these are two completely irrelevant and unrelated classes that just implement an interface, and this perfectly works fine. So these classes are not related, and that's the main difference between abstract classes and interfaces. With an interface, we have different classes that implement this interface, but they are loosely coupled. They are not related with each other. They can be related if we want, but it's not necessary. But with an abstract class, we expect that the classes who will inherit from it, they are related because there is an inheritance in place. Similar to an interface, we cannot use an abstract class to create, to instantiate objects, but they can be used as a type annotation for existing objects. And these are the main characteristics of a class. Now, let's move on to our last contestants for today's battle, enums. Okay, stop. This doesn't compare at all with all the other types. Enums are not used to to describe object structures. But I promise you in the beginning of this episode to compare type aliases, which can act as an enum with the actual enums. So let's see first their syntax. So here we have the file types alias that we described before, and here we use it to create a variable type and assign the mp3 as a value. Now let's see how this compares to actual enum. So we can create an enum file types enum. Again, I'm using a different name just to avoid the conflict here. The syntax is pretty different, so we don't need to use an equal sign. All we have to do is put these brackets here and specify the different values that we have. You can use capital letters, or you can use Pascal case. And this is pretty much how we can declare an enum. You will see that here we are using the actual mp3 value, so this is a string, but enums by default have index. So for example, this has a value 0 and this will have the value 1. So all we have to do is to actually specify that the mp3 has the mp3 as a value and our mp4 has the mp4 as a value. And now this will have the exact same result as our type alias here. So if I have to compare these two syntaxes, I will go with this one, which is much simpler, but if I have a lot of them, then I will definitely go with this one, which is much more readable. And now to implement this, we can go here and use the file types enum, and then here we need to remove the string and use the file types enum again, and we can say .mp3, and this will have the same result. Obviously we don't need this here, and I think we are ready to go. So as you can see, the syntax compared to before is pretty similar, but this is a little bit more structured. The biggest difference compared to enums and type aliases is the fact that enums are available at runtime. So if you declare an enum like this, then this will be available in your actual application. But if we use a type alias, we know already that it will be completely removed. You can avoid having your enums at runtime if you simply use the const keyword here, but yeah, pretty much that's the difference. I would say that if you know that you have a certain amount of value, so for example, I can have mp3, mp4, and I'm pretty sure that I'm not planning to support anything else, then I will definitely use an enum instead of a type alias. But if you have a lot of values that they can be dynamically generated sometimes, this can be a better approach, because here you can use some additional features that we will learn later on in the following episodes to automatically generate those values here. And that was it for today. If you want to learn more about these keywords, I have a video for each of them, and you can find it in the description of this video. I hope you enjoyed this episode. If you like it, just press the thumbs up button. If you didn't like it, press the thumbs down button. And as always, you can read everything I just told you in my personal blog about types, which also contains the coding examples. It's a nice way to review what we've learned and to keep a reference when you want to come back on this topic later on in the future. Of course, if you subscribe to this channel, you will get more videos like this in your feed. Thank you very much for watching this video. See you in the next one and have a creative day.